two strings are isomorphic if one can be transformed into another by consistently swapping characters. Sounds simple, right? But there's a subtle step which breaks the most first attempts. So let's nail it. So hello guys, I am Rachit Kakkad. Welcome back to the channel where we crush DSA and competitive program questions at a time. If you are here new, then smash that subscribe button and drop a like to it. It genuinely helps to grow the channel. So today we are solving LeetCode question 205 isomorphic strings. So let's get into it. Given two strings S and T, determine if they are isomorphic. Two strings are isomorphic if you can replace characters in S to get the T with two rules. Every occurrence of the character must map to the same character consistently, and no two different characters in S can map to the same character in T. It's just like a mapping in a set. Example one says one is egg and other is ed. Then S E is mapped to A, G is mapped to D. Then consistent. There should be no conflict in no changes in G to D. As G is finely mapped and it should not be changed from G to D. The final map for G is D. No changes should be there. If the changes happen, then it's not a proper one. So we have to return true. Example 2 says F is mapped to B, 1 is mapped to 2. Then the other one should be mapped to 2 only. But the next one, 1 is mapped to 3. So we have to return false as it is inconsistent. Example 3, uh, paper and title. P is mapped to T and A is mapped to I. P is again mapped to T, so that's correct. E is mapped to L and R is mapped to E. All are consistent, no two characters sharing a map. So return true. The second rule, no two character mapping to same target is the most trap that most people miss. The approach should be like we should use the HashMap to store the mapping from the characters in S to T. For each position, three things can be happen. One, the character is already in the mapping. Check it for the character in T. If not, return false. The second one could be the character in S has no mapping yet. Before creating one, check if the character in T is already with someone else, like it is already with mapped with another. If yes, two different character would map to the same target. So immediately return false to that. Third, no conflict. Create the new mapping and continue checking. This is the two-way check which exactly what makes isomorphism work. Let's walk through the code. We have to code in C++ as we are dealing with the DSA. So creating an unordered map first because we have to store the key and value both. That's why. One hash map is connected to S and from S characters in S and other one is character in T. That's simple. We look through both the strings simultaneously. A current character is in S, B is correct current character in T. If A is already has the mapping, check it. Check if the map is it maps to B. If it maps to something else, then mapping is inconsistent. As you know, then we have to return false for it. Sorry for the spelling error. If A is no if A is no has mapping yet, look through all existing mapping and check it if B is already mapped with someone else. If yes, two character can't have the same map, so return false. Otherwise, create a mapping to A and B and return true for it. First, let's hit the run button so we can check if there any error or not. So yes, guys, there was a small typing error in it. I have corrected it, and let's hit the submit buttons first. Ignore the background voice. Sorry for the for inconvenience, guys. Here you can see our solution got submitted. If A has no mapping yet, that would do it. Check it existing mapping, and if there is nothing mapped, then it would create a new map to B and return true. So let's try run on A again. Add I0, A is E, A2 is E, B is A. No mapping for E. Is anyone else in the target? Map is empty. No, then create E map to A. I is 1, A is G, B is D. No mapping for G. Is G anyone else target? Only A is. So no, create G map to D. I is 2, A is G, B is D. G is already mapped to D. D equals D. Consistent, continue, loops, ends, return true. Now, F11 and B23. I is 0, F maps to B. Fine, that's normal. I is 1. 1 has no mapping, right? Is 2 anyone target? No. Create a map 1 with 2. 1 maps to 2. I is 2. 1 is already mapped to 2. But B is 3. 2 is not equal to 3. Here we have to return false, correct? Done. The solution which I have written is having the time complexity. The outer loop is of order of n time complexity, but inner loop scanning all the map values for the duplicate makes it order of n square in the worst case. Space complexity is order of 1 since the map is whole set at most 256 ASCII characters. For this constraint size, order of n square is fine. But let me show you an optimal approach. Use two hash map instead of one. One maps to S and other one maps T to S. Both directions checked in order of 1 per character. So let's me get through this solution once. So let's start with another solution. Let me remove this one. So creating first an ordered hash, unordered map, which is a hash set. Sorry for the background noise, guys. Please try to adjust it for it. I will try to manage it after this. Here, if it is not present in the ordered set of this, so we have to return false for it as we have been checking is it mapped with anyone else or not. So let's run it first, and let's submit this one also, so we can know that our answer is accurate or not. Here you can see our answer got accepted. ST maps to S to T and TS maps T to S. We check both direction at every step in order of constant. Total time is order of total time complexity is order of n. Space complexity is order of 1, that's constant. This is a clean interview answer. Does this two map make a sense? Drop a comment if you wanna have a deeper dive. I will cover that also. And that's it for the LeetCode question 205 isomorphic strings. The key insight is isomorphism is a two-way consistent mapping. Check what direction. One map works, but two map is cleaner and faster. If this helps, drop a like. It seriously means a lot, and subscribe so you never miss a video. I will catch you in the next one. Till then, bye bye, guys.